All right, everybody. Welcome to 4-4. Fight on to our Trojan fans out there. All right, 4-4. Let's get to it. I think you'll enjoy this one. Good stuff. Perpendiculars. Probably should share my screen here with you. And let's do this. Okay. So I'm going to guess that most of what's in this section you're probably familiar with to one degree or another. Usually students have had some of this when it comes to kind of whatever geometry they've had coverage of in elementary school. But so let's talk about a few things. We've talked about various types of angles, but we haven't classified them based on their measures. So a right angle, you probably know, is an angle that has a measure of 90, okay, 90 degrees. An acute angle is an angle that has a measure that's less than 90, but there's something else we need to add to that, and more than 0. An obtuse angle is one that is greater than 90 and less than what? 180, right? Easy way to remember acute versus obtuse. It's acute, it's a cute little angle, versus obtuse. Okay. We already talked about complementary angles. There are two angle measures, or two angles that have measures that sum to 90, and supplementary, same thing, but 180. It's got to be just two of them, not 3 or 4, anything else, just 2. Remember the S and the C thing? Remember how 2 C's make an S if you turn one of the C's around? I love doing that so much. Let's just do it for fun. Remember, so here's the C, backward C, and a forward C makes an S. 90 plus 90 makes 180. Oh my. All right. Okay. Remember, big S would mean supplementary. So angle 1, big S, angle 2 would mean angle 1 is supplementary to angle 2. Big C, it just is complementary. Just a lot easier to put a big C in between those than to write all that out. And again, we're getting real close to starting that trek up Proof Mountain. We're going to want all the shortcuts we can get. All right. Congruent angles are angles with the same measure, right? So if the measure of angle ABC is equal to the measure of angle DEF, that means that angle ABC is congruent to angle DEF, okay? So again, this is kind of like number equals number. This is set of points has the same shape and size as this set of points, okay? And that's a little symbol we use. It's an equal sign with a kind of wavy sign. So it's basically, you'll learn what this means. It means kind of similar to, but then equal. So it's similar and equal, then it's congruent. Okay. So we did some of this previously, but let's do another one of these. So what is the measure of an angle if its supplement is 4 more than 3 times its complement? Remember, measure the angle is X, then what's the supplement? 180 minus X, the complement, 90 minus X. Okay, so I have it here actually. Should have had this covered up, I guess, but oh well, it's a freebie there. So here's the measure of the supplement is equals 4 more than 3 times the complement. 3 times the complement, 4 more than that, add 4. All right, so go ahead and solve that. Pause the video, and then come back when you're done. And hopefully you got 47. And you could check that very easily. What's the complement? 43. What's the supplement? What is it? 133, okay. Is 3 times 43, because remember, that's the complement. 3 times 43 is 129. Is that 4 less than what the supplement was? Remember, the supplement was 133. 133 is 4 more than 129. So yes, it does work. Check, check. Okay. Another definition, this is actually new here. 2 rays are perpendicular if they are the sides of a right angle, okay? 2 lines are perpendicular if they contain a pair of perpendicular rays. The bottom line, any combination of lines, rays, or segments are said to be perpendicular if each of them is a line, ray, or segment. 2, they intersect. And 3, the lines containing them are perpendicular. In other words, they form a right angle, okay? So here we have a line, an array. Here we have two rays. Here we have two lines. We also have segments inside there. We have a segment there, okay. So anyway, right angles form perpendiculars, but if you have perpendiculars, then they form right angles, okay? All right, so let's look here. Example 1, if angle 2 is congruent to angle 3, list all the supplementary angles in this figure. So careful here, see if you can do that. I believe there are four sets, yes, 4 sets. See if you can get them all. All right, I'm gonna uncover them. Okay, so we have angle MPQ with angle 3, right? Those form a linear pair. We have MPQ with angle 2 because if 2 is congruent to 3 and 3 was a supplement with angle MPQ, then 2 would be. And then vice versa with this upper MPD with 2, MPD with 3. Okay. All right, we have MF, ray MF, perpendicular to ray MQ. If the measure of AMF is 37, find the measure of QMC. Okay, think about how you would go about doing that. Give it a shot. Okay, well, we know from perpendicular that this is a right angle, so we can put our little box in there, which means 90 degrees. Well, if that's 90 and that's 37, the whole side of this line is how much? 180. Then this just needs to be 180 minus 90 minus 37, which is 53. Okay, and then it says name 2 pair, or it should be pairs of supplementary angles. There's actually more than that. Hopefully you can see how that would be. But one way would be angle FMA and FMC, QMC and QMA. We could do QMA and, wait, I said that, QMC, didn't I? Yeah. I guess there are 1, 2. Yeah, I guess is there just 2 ways of doing that? There's this one with this one, and this one with this one. I don't see another way, another pair. Yeah. Okay, cool. Anyway, that's it for the lesson. Pretty straightforward. And this will be our last video lesson for a little bit. I want to do proofs kind of with you guys. So we're going to switch gears and get back to doing it the old-fashioned way. And looking forward to giving that a shot. Have a good one.